The second sampling strategy that we'll cover is systematic random sampling. Systematic random sampling is a variation of SRS and can be used when it's important to maintain the distribution of one or more attributes of the population in the selected sample. Sampling units are ordered and selected according to a random starting point and sampling interval. The same interval is typically used throughout the drawing of the sample. An example of systematic random sampling is sorting a list of participants by geographic region, then sampling to ensure that the sample represents all geographic regions in the same proportions as they are in the full population. One advantage of systematic random sampling is that it allows a sample to be taken while the sampling frame is being finalized, so it can be used when a full list of participants is unknown. Another advantage is that, like other types of random sampling, each unit has an equal probability of being selected, and data is self-weighted. A disadvantage of systematic random sampling is that the interval used when drawing a sample could, in some instances, match some underlying structure within the sampling frame, thus biasing the sample. Drawing a sample using this strategy is also slightly more difficult than SRS. This sampling strategy can be used when it's important to maintain the distribution of one or more attributes of the population in the sample. Because systematic random sampling allows a sample to be taken before the sampling frame is finalized, you might use this strategy to collect baseline data while participants are still being enrolled in the program and the full list of participants is not yet complete. Systematic random sampling can also be used to mitigate the need for enumerators to travel back and forth from different locations within a village. Here's a diagram that graphically depicts systematic random sampling.